Welcome to landing gear for the Airbus A350-900. This particular lesson is divided into sessions. Session number 1 is overview and introduction. Session 2, doors. Session 3, main landing gear. Session 4, nose landing gear. Session 5, wheels and brakes. Session 6, extension and retraction systems. Session 7, nose wheel steering, and our last session, session 8, is tire pressure indication system. Let's start with session 1. We'll just kind of give you an introduction to landing gear. What is the importance of landing gear? How important is it, really? If you've heard stories already, you know the importance of it. It may not necessarily be the high cause of fatalities. However, it has caused extensive damage to the structure of aircraft if they have a failure of that landing gear. A case in point, FedEx, they had an express cargo plane that was flying from Memphis, Tennessee to Fort Lauderdale Airport in Florida. This was in October of 2016. And the plane, when it landed, the part of the landing gear, I think on the left side, ended up collapsing, causing the plane to obviously make more contact with the runway, which created a lot of friction and impact. Came in too hard and too fast. It started a fire and caused a fuel tank explosion. So I don't know what the dollars are in damage of the aircraft. Luckily, the 2 crew members, we're talking about the pilots on board, were able to escape on the right side because it was the left wing that actually caught fire, and that's where the left engine exploded, that whole area of the aircraft. And they actually got out of the first officer side window and escaped without any injury. So you can see how this how this can affect the entire aircraft. Again, and there in some cases, you could have injury to passengers as well. In this particular story, what was the cause? And you probably know from being around the aircraft maintenance industry that it doesn't take much for thousands and thousands of dollars to, have a cost with the damage from just something simple as corrosion, which in this case turned out to be the case. That is, in the investigation, they did determine that it was due to a crack. Well, a crack occurred only because there was weakened metal. Weakened metal gets weak because of why? Because of what reason? Because of corrosion. So what they found was a corrosion pit that was in the radius between the diameter and the airfill valve bore of the outer cylinder of that landing gear. And that's all it took. It weakened the whole thing, and then of course obviously caused the whole landing gear assembly to collapse. They found even further that the corrosion pit would have not occurred, more than likely, highly not likely it would have occurred, if there had been cadmium plating, on it. And that's actually something that Boeing had sent out an alert service bulletin about, and the MRO completely ignored, or maybe they just didn't get around to updating their maintenance procedures for doing that. But that was the cause of that, as determined by the investigation. Cadmium plating was not applied to the radius during the last time that plane was overhauled. So something simple causes something great. So just keep that in mind when you're doing maintenance. If you're unsure about something, what I suggest is becoming more in tune and aware of the current, the bulletins that are put out, and just learn it on your own. Because what if your employer didn't get around to updating that and putting that in there? Then you're going to be doing work and perhaps missing a step that was required. That's something that was dictated by Boeing for them to do. So anyway, that's the story on the FedEx cargo plane. So what does landing gear do? I mean, you can think about the size and weight of the aircraft. That's a lot of weight for landing gear to be supporting. But that's what it does. That's what it's designed to do. It helps the plane make a smooth landing. because belly landings are a risk, right? When you have a belly landing, what happens? You don't have necessarily an even balance from left to right. You might think you do because, well, there's the belly, right? But it's like it's a tube. So the tube can roll to the right or the left. And in many cases, that's exactly what happens. Of course, there's a point where you obviously have the wings, so they're going to hit the runway as well and create a stop. But if it, on impact, comes at a very high rate of speed, it's enough to break wings. So then you're going to have a rolling that goes on. So that's one risk you're going to have is the plane's going to flip. It could catch fire, as we know, and of course, with all of catching fire, now you can get the fuel tanks involved in containment, and now you have an explosion. So, helping the planes make a smooth landing is extremely important, obviously. And then again, it's there to support the incredible weight that we have at landing speed. It acts as a shock absorber. You also have the wheels. The wheels have brakes, and that helps to slow the plane down more. All right. So it's pretty tough. I mean, it'd have to be. When you think about the material that it's made of, it has to be strong enough to handle 500 metric tons, in addition to the forces that are involved when the plane actually lands and makes contact with the runway. Okay, so the steel that is used there, again, if you have the proper plating of that steel, then you're going to have obviously a lower chance of any corrosion to that landing gear at all. But there's the steel there, and it also is using the physics of oil and gas. The gas I'm referring to, by the way, is nitrogen that's involved in that, and that's just that mechanism to create that absorption of the shock energy that happens upon impact. Okay, and that's received in the struts. Also in the Airbus A350's gear, they're tilted a little bit. That's just, in some airplanes that might not be the case, but I'm just sharing that with you. It's tilted a little bit forward, so that means the front tires may make contact first before any other tires. So, well, that gives you an idea on the importance of landing gear, and giving you an idea also on the different components and systems within the landing gear that we're going to be discussing in further detail as we continue on with the sessions. All right, let's go ahead and continue. I'm going to give you a test question right now. You may see it on the test. All right, how many metric tons, estimated, okay, how many metric tons can the landing gear support? Is it 100 tons or 500 tons? You're right. The answer is 500 tons. And I was mentioning metric tons. That's what it is. All right, that concludes our session 1 as the introduction and overview. And we're going to go ahead and move on to our session number 2. This is session 2 on landing gear for the Airbus A350. We are now on to doors, the landing gear doors, and actually how they open them, close them. The landing gear ground door opening systems. And you have the main landing gear door opening system as well as the nose landing gear door opening system. This is obviously opening up the bay's doors for maintenance purposes. There's 2 types of release devices. The one that's the latch release is the one for the main landing gear door opening system, and the button release is the one for the nose landing gear ground opening system. Alright, so that may be a test question. Which kind of handle release device is used for the ground door opening system for the main landing gear? Is that the latch release style or the button release? That's the latch release kind. So main landing gear has a latch release style of handle. Okay, so those are 2 different kinds of handles. Alright. Also, you have a fuse pin that's there attached to that mechanism of the handle, so that in case you all decide to become Hercules and put in too much force on that handle, it won't break it. There's that fuse pin there to prevent it from being, broken from too much force. The handle itself is actually connected or is operating two different things. That's going to be the bypass valve and the door up lock. That may be a test question. So it operates a bypass valve and a door up lock. And it has, the handle is actually connected to the door bypass valve, which moves to a bypass position. Okay, so what is this doing? The whole idea with the bypass valve is it's going to be isolating the door actuators from the hydraulic supply line. And instead it's going to be connecting the two actuator chambers to let that free fluid circulate. And then it's the other, a component that it's connected to is that door up lock assembly, so that it can unlatch the actual door to the bays. So it's actually rotating a hook so that it can release that door. And then after that, of course, gravity is going to take over and the door will open. All right, so just keep in mind about the fuse pin, etc. You may see that as a test question. All right, so let's look at this. Question number 3. What two things does the handle operate? Is it A, the fuse pin and the pressure relief valve, or the door up lock, and I mean the door up lock assembly, and the bypass valve? That's going to be option B, door up lock assembly and the bypass valve. All right, so that gives you an idea with the types of the handles for the main landing gear and nose landing gear as well. All right, we're going to go ahead and move on to our session 3 into the heart of landing gear, specifically for the main landing gear. We are now on to session 3, main landing gear for the Airbus A350. What are the components that make up the main landing gear? Well, there are different components. There are side stays, shock absorber leg, a 4-wheel bogie beam assembly. You also have 2 lock stay actuators as well as a retraction actuator. There are 2 pairs of downlock springs and a hydraulic pitch trimmer. There are also torque link and other side stays with the lock links. Also, if you needed to access any main landing gear attachments, you can actually do that by accessing an over-the-wing panel, access panel that's there. All right, let's start with describing some of the components with the bogie beam assembly. What do we have here with this particular piece? Well, on the bogie beam assembly, there are different components. It does have 4 wheels. That's, by the way, you want to highlight that because that's going to be on the test. Okay. And with the bogie, we have a front and aft jacking dome. There's also brake tie rods that are attached to the bogie beam, and they're just there to transmit the braking effect from the brake units to the aircraft through the main landing gear. There's also the axle sleeves that have a wear surface for the brake units and the wheels. And there's also on the actual bogie axles, there's a paint that's heat sensitive. And the only way it really shows up is when it gets really, really hot. And that's just an indicator that those bogie axles have gone, past a certain temperature. And what about the landing gear pitch trimmer? This is a hydraulic pitch trimmer. Well, with this particular bogie trim actuator, it's a trimmer actuator. It is a hydraulic actuator, and this is actually installed between the sliding tube and the forward end of the bogie beam. Okay, it's holding the bogie beam in position. All right, and we're going to get into the shock absorber, but the shock absorber has 2 components to that. It's the main fitting and the sliding tube. So what I'm talking about here with the the actuator, the pitch trim actuator being installed between the sliding tube and the forward end of the bogey beam. That sliding tube, again, is part of the shock absorber. And what's the purpose of the pitch trimmer? Well, it's two things. Number one, it's going to make sure that the wheels are correctly aligned in the bay. And number two, it's going to absorb bogey oscillation, which occurs when the aircraft is taxiing or landing. Okay. Another part of the actuator is a bleed screw, and that just enables the maintenance technician to bleed air from that actuator. There's also a fuse that's going to prevent the loss of hydraulic fluid. So if there's a leak downstream of the fuse, then the fuse is going to close to prevent the leakage. Okay, and once the leak is fixed, then it actually auto resets. All right. Okay, let's go ahead and now go into describing the shock absorber. Like I was saying earlier, there's two parts to it. There's an upper outer cylinder, which is called the main fitting, or referred to as the main fitting. You also have a lower inner piston, which is that sliding tube. This mechanism is a single-stage oleo-pneumatic unit, and there's no separation between the gas and the oil. The gas I'm referring to is nitrogen gas. Okay, so you may see that as a test question as to whether or not the nitrogen gas and oil are separated or not. What about ports? There are ports on the main fitting. Okay, and what are the ports for? Okay, which is which? Because there's one at the top and one at the bottom. There's one for the gas filling. There's one for filling gas into it, and then the other one's for the oil. The top one is for the gas, and the bottom one is for the oil filling. There's also a changeover valve that's installed on the lower part of the main fitting. And what is this changeover valve for? Okay, well, let's describe it a little bit. The changeover valve is going to be actually like a kind of a mechanism as a backup, because itself it doesn't, but it's allowing the primary seal, if for whatever reason it's not functioning properly. The primary seal, by the way, is at the bottom of that main fitting, and then you have a secondary seal which is at the top. These are dynamic seals, and it's just going to obviously keep the pressure of the oil and nitrogen, contained. So in a normal configuration, the primary seal, which is at the bottom, is the one that's going to be absorbing the shock. Again, if for some reason that's not operating correctly, then with the changeover valve, the secondary seal is going to take over. Okay, and this is going to be done manually. This is a manual operation. And that secondary seal, again, is going to do the same job as the primary seal if it were working. So it's creating that pressure to make sure it's equal on both sides. So in a normal configuration or normal operation, there's a green band on that changeover valve and around it, and that just indicates that the primary seal is being used. If there is a leak, then after the changeover valve and the changeover occurs, then you're going to have that band be in the color of red. All right, so that's what's going on with that changeover valve. Okay, it's relating to the dynamic seals, primary and the secondary seals. All right, let's go to some test questions, some potential test questions. I forgot to mention earlier. Let's just follow along in your review notes and your video notes and review sheet. And we're on question number 4. This is a continuation from sessions 1 and 2 where we had questions there. All right, so question number 4 is true and false. The bogey beam assembly has 2 wheels. Is that true or false? That's false, because it has 4 wheels. Question number 5, name one function of the landing gear pitch trimmer. Is it A, it makes sure that the wheels are aligned in the main landing gear bay, or is it B, it makes sure that the sliding tube is aligned? Okay, the answer is the first answer. All right, so let's have one more question. Okay, where is the gas filling port for the main landing gear? Is it at the top or the bottom of the main fitting? Okay, you're right. It's the first answer. It's at the top. The oil is the one it's at the bottom. Okay, that filling port. All right. Okay, if you have any questions about this session, please feel free to email those questions to us, and we will do our very best to get answers to you. We'll go ahead and continue with our next session. This is session 4, nose landing gear for the Airbus A350. The components of the nose landing gear are very similar to that for the main landing gear. So just to give you an idea with the different components, you do still have a shock absorber, which is a main fitting and a sliding tube. You have torque links, a drag stay. This is a little bit different. We didn't talk about that or mention that in the main landing gear. We specifically are referring to the drag stay assembly with the nose landing gear. Then of course you have your lock stay actuator, your down lock springs, your retraction actuator, and steering actuators. Shock absorber is similar design to the main landing gear shock absorber, which is an oleo-pneumatic type of absorber. And then there's a drag stay assembly. The drag stay assembly is composed of 2 parts. You have an upper and a lower, and its function is to keep the nose landing gear legs stable when the nose landing gear is extended. And okay, during that time also you have tension in the downlock springs and hydraulic pressure in the actuator to put the lock link in its over the center lock position so everything's aligned properly. When you have a free fall situation with that, then the tension in these springs are going to make sure that the links will mechanically go to that locked position. Now also, as far as steering goes, the nose wheels are steered by 2 double action hydraulic actuators, which are attached to the main fitting. Okay, so it gives you an idea with the different components. A little bit on the shock absorber ports and the changeover valve, just to reiterate, because they are extremely similar to what we talked about with the main landing gear. But here, with the shock absorber, it does have the outer and the lower inner piston. You also have the gas filling port, which is at the top of the main fitting, and the oil is at the bottom. And then that changeover valve is installed on the lower part of that main fitting for that same function as I mentioned in with the main landing gears. Just having a backup when you have 2 dynamic seals that I mentioned before, right? And if you have a leak with the primary seal, then the changeover valve allows the secondary seal to close to secure the pressure of the oil and the gas. So that's pretty much all for the nose landing gear information. You still have, again, the sleeves and a jacking dome with the tube, that kind of thing. So that's all we have to say. We're going to go ahead and move on to session 5. Welcome to session 5, wheels and brakes for the Airbus A350. This is session 5, wheels and brakes. There's a lot of information regarding the wheels and brakes, but we will get through this. And the first question is, how many wheels are there? We're talking about the main landing gear and the nose landing gear. There are 8 wheels for the main landing gear and 2 wheels for the nose landing gear. And there's 2 ways to look at the way that they are ordered. There's 2 wheel assemblies, and each of those wheel assemblies have 4 wheels each, and that's for the main landing gear, by the way. And then there's also a designation or grouping, if you will, of the wheels in total, like all the 8 wheels, and that's grouped by the forward wheels versus the rear wheels. So the forward wheel group is numbered from aircraft left to right, which is 1, 2, 3, 4, because those are your front wheels. And then you have your rear wheels, which are numbered 5, 6, 7, 8, aircraft left to right. So I know it seems a little bit confusing, but a diagram can help when you look at these. But when you're talking about wheel groups, they're referring to position of those wheels, whether or not they belong to the two. They're belonging to two wheel assemblies, two separate wheel assemblies, but those are the wheels in the front. Okay, now what hydraulic systems are supplying what? Okay, which groups? We have a yellow hydraulic system that is supplying the forward group, and the green hydraulic system is supplying the rear wheel group. Each of the wheels also has two valves for protection. One is an inflation valve and the other one is an overpressure relief valve. One of the dangers to aircraft mechanics is being in the line of fire, so to speak, with the potential of tires bursting and exploding, and you don't want to be in the path of that force. So the caution is, if you have a rejected takeoff plane, and then what you want to do, you don't want to start doing maintenance right away after that happens. You want to typically wait 1 hour, at least 1 hour. Do follow what your procedures are at your MRO, but the longer you wait, the safer you are. Before you approach the airplane, before you approach the landing gear, it's very important. So what you want to do is you want to approach it from the front or the rear, not the side. Okay, so not the side of the wheel. All right, how about a test question? Potential test question already. How many wheels does the main landing gear have? Is it 4 or 8? It's 8. Okay, and question number 8. Okay, this is from your video notes and review. Just follow along with that. But question number 8, which hydraulic system supplies power for the forward wheel group? Is it yellow or the green hydraulic system? Okay, it's going to be the yellow. The yellow is what's supplying the pressure for the forward wheel group. Which hydraulic system then supplies power for the rear wheel group? Okay, is that yellow or green? Okay, I just mentioned it. The other one's yellow, the other one's green. Okay, so the green hydraulic system is supplying the power for the rear wheel. All right, let's do one more review question right now. Which two valves does each wheel have? Okay, that's going to be your inflation. That's your inflation valve. And the overpressure relief valve. Those are your two. Let's go ahead now and talk a little bit about the braking control system. Okay, there are 4 modes of operation on the braking control system. There's the normal, the alternate, the emergency, and the parking/ultimate braking mode. And for the normal mode, you're going to have your high pressure hydraulic systems, which are your yellow or green hydraulic systems. They're going to be supplying the power. As far as your other modes of operation that I just mentioned, those are going to be supplied by 2 accumulators. Okay, so keep that in mind because that might be a test question. Now, since I'm talking about accumulators, I want to go ahead and share with you about the circuit pressurization and depressurization of the accumulators. Because another thing that's part of the normal hydraulic circuit, which I'll get to in a little bit, or the normal braking circuit, is involving the accumulator refill valves. And obviously those are going to be to refill the accumulators, and those are going to be taken from the hydraulic high pressure systems, your yellow and green. But they're manually controlled to open from the accumulator refill or push button in the cockpit. There's an ACCU refill push button in the cockpit that can be obviously depressed. There's also an automatically controlled way to refill, and that's going to be when it's doing that, it's going to be to open after the engine start. So after engine start, when the master level switch is on, and before landing, when the landing gear is set to down. And then of course your engine, we talked about this in hydraulic power lesson, you got your EDPs and your EMPs, your electric motor pumps and engine driven pumps that are used to pressurize those high pressure systems that are going to refill those accumulators. Alright, so just a little bit on that. And then just note that you have a manual lever that's going to enable that circuit depressurization in case you have to do maintenance on the accumulators. All right, so let's kind of go back. And so now you know that the accumulators are supplying power for those alternate modes, right? So let's kind of talk about some of the computers that are involved with this whole thing of braking, and kind of get a feel for what the normal braking circuit architecture is about. But one of the computers that's involved, or a couple of them we can talk about, are the CPIOMs. Okay, that's your core processing input-output module, which by the way has multiple applications. Here I'm specifically talking about the braking control system app. And then you also have your remote braking control units both of these are going to be controlling and monitoring the braking modes for different things. That includes temperature and just the pressure. The pressure is the main thing, right? Pressure and temperature and quantity of fluids in any system that I've talked about before, no matter what. If you have a failure, for example, of the auto flight data exchange network or of the CPIOMs, then you're going to have the remote braking control units that are going to be able to provide the controlling and monitoring of those braking modes. Now, let's look at a normal braking circuit. What does that look like? Well, you have transducers. You've got to, because you've got to get feedback signals back to the computer. So you've got pressure transducers, you have safety valves, which are in the form of fusible plugs, okay, or fuses, and those are going to obviously isolate the brake supply from the leakage downstream of the fuse. And then you also have your normal brake selector valves. Okay, those are going to be open to connect to the main hydraulic supply. It's going to be doing that through a servo valve. So you do have a normal servo valve along with the normal brake selector valves. Okay, they're also isolating the braking circuit from the hydraulic supply when the braking is not being used at all. So you've got that. Remember I mentioned the two accumulators? Okay, that's part of the normal braking circuit. I know that I mentioned those it's what's supplying the alternate modes of braking. When we talk about the normal, I'm just simply stating that you have two accumulators, one for each of the main high pressure hydraulic systems, your yellow and your green, right? And those are supplying to your normal mode. You also have two shuttle valves for each wheel group. What is that doing? Okay, if you understand about shuttle valves and some of the different kinds of valves and their functions, the shuttle valves here in this particular case are here. And what they're doing is selecting the highest pressure that's supplied by either the normal or alternate circuit so that it can be going to the single cavity brakes. Then you also have the alternate refilling valve at your ARV, and that's going to be for each wheel group. Okay, you also have an alternate brake selector valve for each wheel group. That's going to open so that it can connect the hydraulic supply from the accumulators to the servo valves, but now this time not the normal but the alternate servo valves, again to isolate that braking circuit when the alternate braking is not being used. Okay, so you have a lot of isolation functions going on with these circuits. Okay, so we have normal braking circuit and alternate as well. Your parking brake system, you have a hydromechanical setup when it comes to the parking brake system, because you have some valves and equipment shared with the alternate emergency braking system circuit. So there's a connection between the parking brake system and the alternate emergency braking circuit. Okay, so the pressure there can be applied with or without an electrical power supply. There's two park brake selector valves in the system. There's one on each of the wheel groups. Okay, and those again are connected to the accumulators. So a lot of different components there, but obviously all necessary to be doing the job. All right, so let's just make sure we don't have any review questions to mention. All right, so so far you've gotten an idea on the normal braking circuit and the normal braking mode op. I want to go into a little bit more on the normal braking mode, because we're looking at some what are the kind of kind of the functions or the systems that are there in place that are involved with that. And here in normal braking mode, it's including the functions of the retraction braking, auto braking, and pedal braking. So why do we have so many? Well, it's always good to have redundant systems. So these are different ways that you can have a normal braking mode in all the three I just mentioned right now. Okay, and of course, it can be using the CPIOMs like I mentioned before, as well as your RBCUs to make that happen. You also have some wheel tachometers. Those are your gathering your the speed. Okay, the speed of that, so you get wheel speed data, and also your aiders, ground speed data, and those are all received from the RBCUs. All right, so just a little side note, when you have your retraction braking, the retraction braking, by the way, does not give the anti-skid function. So the other two do, your pedal and your auto, but not the retraction braking. Okay, so let's go ahead and move on to alternate braking mode and get a feel for this. Your alternate braking mode, you have just two. You don't have the retraction braking, you have just the pedal and the auto braking functions. So if you have a normal braking mode, that's going to fail. The alternate braking with the anti-skid is going to take over. Okay, so your anti-skid mode are going to include the functions of your pedal and your auto braking. Okay, and of course you've got the, like I said before, all these signals are going on once that is applied. You've got electrical signals that are sent to open up the selector valves to control the pressure to the brakes. That's the heart of all of that. Okay, now what about the emergency braking mode? Your emergency braking mode, when do all the brakes go into an emergency mode? That's going to happen when the anti-skid switch is in an off position. Okay, so you may see that on a test. Okay, so that's when you have the emergency braking mode. Okay, when that anti-skid switch is set to off and all brakes change to the emergency mode. It's similar to the alternate braking, because usually, and when we talk about, gosh, I think even, well, no, I was talking about the A320. We think of alternate, you think, well, alternate operation means, okay, something broke down. That's why now we have this alternate. It's almost like a euphemistic word for emergency. In this case, they are two different things. That's why they're listed the way they are. But emergency brake is similar to the alternate braking, but the emergency mode is without the anti-skid. So just keep that in mind. And that only when you have the pedal braking available, that's when you have anti-skid. There's also a maximum pressure of 1,000 psi without the anti-skid protection. Okay. All right, so that gives you an idea with the emergency brake operation. Okay, now a little on the parking brake. There's a parking brake handle. Okay, the parking brake is operated, and once that operates, that's going to kick in the entire circuit. That's going to supply the pressure to all the brakes. Okay, so when you have a parking brake mode, the handle will directly control those selector valves so that it can supply 3,400 psi to the brakes. Okay, remember I said that the high power, your high pressure hydraulic systems are going to be supplying pressure in the normal mode. Well, here I'm talking about the accumulators that are going to be supplying. So that pressure of 3,400 psi is coming from those accumulators and going to the brakes. Okay, now there's a sort of a limit of the power that's available from these accumulators. They're just backups. They're kind of like a quick fix, if you will. But they're only good for about 12 hours. And then, it's something else. But anyway, by the way, that's what it is. And if you have a problem with, if the parking brake mode is in a low pressure condition, then it is possible for the normal braking mode to be recovered. And how is that possible? It can actually be recovered by depressing the pedals. So that's possible for that to occur. All right, and what about bleeding the brakes? Okay, what if you have to do maintenance on this stuff? I mean, what if you needed to bleed out the pressure? You got a braking system bleeding procedure. It's a small brake pressure that's applied. It's not much, but there's an interactive mode that's going through a special function menu. This is the landing gear menu, by the way. And what it's doing, it's sending the hydraulic pressure to the brakes without actually operating the pedals. The menu is the same as for a wheel change. So when you see it on the display, it's not much. Like I said, it's just a little bit of pressure. And that's just making sure that the safety valve doesn't close if the brake bleeding valve stays in the open position during the time that you're bleeding. Okay, the brakes. So just keep in mind that you want to follow step by step, because according to experience in the field, if you don't follow them very carefully, you're going to have even more work to do. Then there's the brake temperature monitoring system, because brakes can get really hot. So there is a temperature system that measures the temperature at each of the brake units, and it's going to send that data to the common display system. And what it's checking specifically is at takeoff, they don't want to have a hot brake, and then also the landing gear retraction. We don't want to have a hot brake there as well, because what's going to happen in the bay is it's a potential to have a fire. And then you want to also monitor the residual braking. So you have this whole system. You also have obviously a sensor that's installed in each of the brake units, and that's going to be supplying an output voltage in proportion to the temperature. So that's how that sensor works. The outputs are sent to the brake temperature compensation module, and there's going to be one for each of the bogies, and those are senses the temperature, and also sending that analog signal to another computer. That's going to be your wheel remote data concentrator, and that data is transmitted through the remote braking control unit over to the landing gear management system that's part of the CPIOMs. So there's the importance. Just wanted to point out and make sure I did not be remiss in mentioning to you that there's a very high importance of monitoring the temperature on those brakes, and there was a system in place to do that. All right, this concludes session 5, and we will be continuing on with our next session.